Good morning, student. Today is the last session of second unit. The last topic is Bernoulli's rule. So today let we learn the Bernoulli's rule. Very important. You will get 5 marks. So yesterday what we learned is integration by parts. Now today we are going to learn Bernoulli's rule. So what is relation between this Bernoulli rule and integration by part, that is product. So in a product rule, if you take the problem, if integration of e power of x into sine x, if you take e power of x into sine x, then if you apply product rule, so sine x is trigonometric, that is a first function u, and e power of x is exponential, that is a second function v. Then if you go and apply the product rule on them, then what happens is it is a repeatedly product rule should be applied. And if you take x square into e power of x square is algebraic, u is equal to x square, and v exponential v is equal to e power of x, and if you apply product rule you have to apply it for 2 times. If it is x power of 10 into e power of x, then we have to apply product rule for 10 times. So instead of applying product rule for repeatedly, then we have to use Bernoulli rule. Are you getting me? That's only a simple point I am telling. What is that? What is the relation between Bernoulli and product rule? Repeatedly, instead of applying repeatedly the product rule, we can apply Bernoulli's rule. That's what I want to tell you. That's it. Are able to get me? Yes. So this is what I want to tell you. So let me go to the Bernoulli's rule. What is the Bernoulli's rule, and what are the problems on Bernoulli's rule? You will get 5 marks damn surely on Bernoulli's rule. That's it. So let me go to what it is actually the Bernoulli rule is. So now Bernoulli's rule. Integration of u into v into dx. Integration of u into v into dx. That is a product of two functions. Product of two functions. Integration of u into v into dx. Integration of product of two functions. But when we apply the Bernoulli rule is among these two functions, that is u and v, among these two functions u and v, one should be an algebraic function. So if one of them is algebraic function, then we apply Bernoulli rule. And that algebraic function is greater powers of x. Not simply x. It may be x square, x cube, x power of 4, x power of 5, x power of 10, x power of 11, like that. So I am giving one first condition when we are going to apply Bernoulli's rule. We are going to apply Bernoulli's rule only when one of the function, there are product of two functions, means there are two functions. Among the two functions, one of them must be algebraic function. Not only algebraic doesn't means it's only simply x. It has a greater power of x. That is, it should be x square, x cube, x power of 4, x power of 5, x power of 6, like that. So then only we are going to apply Bernoulli's rule. Are you getting, guys? Are you getting me? Very simple one when we are going to apply Bernoulli's rule. So for the identification of the problem, you have to know this information. So by seeing the problem, you can able to identify, yes, this problem I can do by using Bernoulli's rule. So which problems you are going to do under Bernoulli's rule? So it should be a type of product rule, that is a product of two functions, integration of product of two functions, but among the two functions one should be algebraic. I am only talking at a diploma level. That's why I am directly saying in a diploma level, if you want to evaluate integration of product of two functions, among them one is algebraic function, that is not simply x, it should be like x square, x cube, x power of 4, x power of 5, like that. Then we are going to apply Bernoulli rule. So here the question arises. So straightforwardly the question arises. Why? If it is x simply, if it is algebraic, one of them is algebraic and it is only simply x. Can't we apply Bernoulli rule? Yes, we can apply Bernoulli rule, but as simply as you can also apply product rule. You will get, if it is x, if it is x instead of x square, x cube, x power of 4, it is only x, then you can directly apply product rule, that is integration by parts. And you can apply Bernoulli rule. No way you can apply Bernoulli rule, and Bernoulli rule and product rule both are becomes the same in that case. So what is use of this Bernoulli rule then? The Bernoulli rule is, why it is so important is because instead of x, if you are having x square or x square, then you have to apply product rule 2 times. If it is x cube, then you have to apply for 3 times. If it is x power of 4, then you have to apply 4 times product rule. So applying repeatedly product rule is tedious. So instead of that, you can directly apply Bernoulli rule once. That gives the answer. So are you getting the beauty of Bernoulli rule now? I think you are able to get what is concept behind Bernoulli rule. The simple concept behind the Bernoulli rule is that instead of applying repeatedly product rule, you can apply Bernoulli rule. That's it. Instead of applying repeatedly the product rule, you can apply the Bernoulli rule. That's a very simple. But there is a condition to apply the Bernoulli rule. That is, what the simple condition is, among the product of two functions, one of them must be algebraic. It should be algebraic. And why it should be algebraic, I am going to tell you now. Now listen carefully. Are you able to get it up to now? So why Bernoulli rule we use? We use it instead of applying product rule repeatedly, we use Bernoulli rule once. That is a use of Bernoulli rule. And what I am telling is, and we will find, we apply Bernoulli rule to evaluate integration of product of two functions, and among those two functions, one of them must be algebraic. That's what I told you. And not only in algebraic sense, it should not be only x, it should be like x square, x cube, x power of 4, like that. Then only the essence of applying Bernoulli rule will come out. So why should be algebraic? And why should the powers are same? And if, I already told you, if instead of x square, x cube, x power of 4, if it is only simply x, then you can solve the problem by using integration by parts. That is a product rule. And you can also solve with Bernoulli rule. So there is no difference between integration by parts and Bernoulli rule if it's only simply x, that is x to the power of 1. One of the function is x to the power of 1. Are you clear? Is it clear? So up to now you are clear. Now I am going to answer to that question, why one of the function should be algebraic. Why the condition is there that in order to apply the Bernoulli rule among the product of two functions, one of them must be algebraic function. Why? You see, now before answering that question, let me see what is the Bernoulli rule. Then automatically you are able to tell why should be one of the function should be algebraic. Are you getting me? Are you getting me? So let me see what is Bernoulli rule, what it says like that. So in a Bernoulli rule, we are going to evaluate integration of product of two functions. One of them is u and second one is v. So first function, I am taking it as a u. First function is u and second function is v. U is the first function and v is a second function. U dash is a derivative of u. First derivative, this is first derivative, second derivative, third derivative, fourth derivative. So derivatives of u. So what you are finding is successive derivatives of u. So for a first function, we are finding its derivative. U prime, u double prime, u triple prime, u fourth prime, like that. First derivative, second derivative, third derivative, fourth derivative, fifth derivative, like that. Now the other side, for v, we are find v1. v1 is integration of v. And v2 is a second integration, double integration, v3 third integration, triple integration, fourthable integration, that is v4. So for first function we are finding derivatives, and for the second function we are finding integrations. So among the product of two functions, I said u is a first function and v is a second function. For u, we are finding all derivatives. U prime, u double prime, u triple prime, first order, second order, third order, fourth order derivatives of u. And for v, for v, v1, v2, v3, v4 all are integrals of v, successive integrals of v. Now, what Bernoulli rule says, you have to cross multiply like this. I am already given arrows and start with plus, plus, minus, plus, minus. That's what I am saying. Are you getting? For u, we are finding derivatives. For v, we are finding integrals. So, as shown in the slide, you cross multiply u into v1 plus minus u dash into v2, u double dash into v3, u triple dash into v4, like that. U into v1 minus u dash into v2 plus u double dash into v3 minus u triple dash into v4, like that. This is my Bernoulli rule. Are you getting what is a Bernoulli rule? You choose the first function. Of course, how to choose the first function? I already told you in integration by parts. That is a product rule. We used the order, that is isolate. To choose the first function, we have to go for the order isolate. Isolate means inverse log inverse. I means inverse trigonometric functions. L means logarithmic functions. A means algebraic functions, T means trigonometric functions, and E means exponential functions. That is the order of isolate to choose the first function, then the second function. So, in this case, what happened? Here, u is the first function, v is a second function. For u, you are finding derivatives. For v, we are finding consecutive integrals, and then cross multiply with plus minus plus minus plus minus. Then the Bernoulli rule is integration of u into v into dx is u into v1 minus u dash into v2 plus u double dash into v3 minus u triple dash into v4, and so on and so on. Are you getting? So this is my Bernoulli rule. Now you see, if you go on multiply, there will be no end. In order to get the end, so at some point of this derivative should be 0. The derivatives at some point is 0, then onwards the terms will be 0, then you can stop the Bernoulli rule. But otherwise there is no end for this Bernoulli rule. There is no end. So the derivatives of first function at some place should be 0. Then only you can apply Bernoulli rule. So at some stage the derivative should be 0 means only derivative of a constant is 0. Therefore the functions should be algebraic. When the first function is algebraic, at some stage, first or second or third, fourth derivatives, at some stage the derivative of algebraic function is definitely 0, then there is an end to Bernoulli rule. So that's why I am saying, in order to apply a Bernoulli rule, what you need is that one of the function is algebraic, so that its a derivative at some stage becomes a 0, and that is the end of Bernoulli rule. Are you getting? Are you getting? And the first function always what is a first function? First function always only algebraic, means the second function should be trigonometric or exponential. Are you getting? It should not be logarithmic, or it should not be inverse. So these are the some conditions to apply Bernoulli rule. That's what I want to tell you. So what is the one thing? Instead of applying product rule, that is integration by parts repeatedly, we apply Bernoulli rule. That is the first one. And second one is, among the two functions, first function and second function, we choose first and second function by the order isolate, and the first function should be algebraic. Why? Because at some stage its derivative is 0, then only you will get the end to the Bernoulli rule. These are the terms and conditions to apply Bernoulli rule, and by this terms and condition only, by seeing the problem, you can identify whether we can apply Bernoulli rule or not. So this is introduction of Bernoulli rule. So I think it's enough with the theory part, so that now we have to move to the problematic part. we have to cover more and more problems because you may not have any material with you. So we should cover in this video all types of problems, so that you can do any type of problem that comes in examination or in any material. So are you getting? So let me try to cover all type problems here one by one on Bernoulli rule. So next 30 minutes we work on only problems. So be careful guys, let us start. So before starting the problems, I want to tell you one thing, that what is that you need to know the derivatives and you need to know the integral formulas, because in a Bernoulli rule, product of two functions, first function we find the successive differentiations, and for the second function we find successive integrals. Are you getting? So, in order to apply Bernoulli rule, in order to do problem on Bernoulli rule, you have to know the differentiation and integration formulas. You see how the formulas are useful in every stage. So this is a beautiful concept of Bernoulli rule, but in that we certainly need the fundamental formulas, the standard formulas of standard functions. That's it. So let me do one by one the problems. Let me cover one by one. So this is my problems part. What we are going to do? We are going to solve as many as that we can in this. So this is my first problem. So how much we can cover? Let me see how much we can cover these problems. I think all this can we cover in this or not. So let it be. Let us try to cover all this, otherwise we can skip one or two. So this is evaluate integration of x to the power of 4 into e power of 2x dx. Look at the problem. You simply look at the problem first. Yes. What is the problem? You see, evaluate integration of x to the power of 4 into e power of 2x dx. Product of two functions, among them one algebraic and algebraic is x to the power of 4. So directly this problem comes under Bernoulli's rule. That what you know as a student of diploma level. First of all, by seeing the problem, can you identify the method? Once, so first of all, keep it aside whether you know the method or not. But can you identify the method? Is it a product rule? Is it a Bernoulli rule? Are you have to apply partial fractions? Are you have to put a t is equal to tan x by 2, or t is equal to tan x, or it is any other substitution, or is it in a sine power of mx or cos power of nx, or directly in a 9 standard integrals, or you have to convert into 9 standard integrals, or directly the simply basic standard formulas. Whether in which form is the problem, you have to identify. The one simple thing that every student should know, that whether problem comes under which method, that you have to know. So now seeing the problem, this is the product of two functions, among them one is an algebraic function, therefore you can apply Bernoulli rule. Now x power of 4 is algebraic and e power of 2x is a exponential. So from the order I late, algebraic is the first function and exponential is the second function. So take u is equal to x to the power of 4 and v is equal to e power of 2x. As for Bernoulli rule, you have to find for first function successive derivatives, and for second function you have to find successive integration. X to the power of 4 derivative, x to the power of n integration is n into x to the power of n minus 1. X to the power of n derivative, x to the power of n derivative is n into x to the power of n minus 1. So x to the power of 4 derivative is 4x cube. Now x cube derivative is 3x square into 4 is 12x square. Now x square derivative is 2x into 12 is 24x. 24 into x derivative is 1, so 24 derivative is 0. So at some stage it should be 0, then only you can apply Bernoulli rule. Now coming to e power of 2x, e power of ax integration, e power of ax by a, e power of 2x integration, e power of 2x by 2, Again e power of 2x integration e power of 2x by 2 into 2 4, and e power of 2x by 8, e power of 2x by 16, e power of 2x by 32. Are you getting me? So here e power of 2x integration e power of 2x by 2, 1 by 2 outside, here in this case. Now again you have to do integration, 1 by 2 outside. Integration of e power of 2x, e power of 2x by 2, denominator 2 into 2, 1 by 2 outside, 2 into 2, 4. Again in this case, 1 by 4 outside, e power of 2x integration, e power of 2x by 2, 4, 2 into 4, that is 8. Again here in this case, 1 by 8 outside, integration of e power of 2x is e power of 2x by 2, 8 into 2, 16. In this case, 1 by 16 outside, e power of 2x integration, e power of 2x by 2, 16 into 2, 32. That's it. Now cross multiply with plus, minus, plus, minus, plus, e power of 2x common, you will get e power of 2x into e power of 2x into x power of 4 by 2 minus x cube plus, are you getting, x by 3x square, this 3 by 2 x square minus 3 by 2 x plus 3 by 4 plus c at last. That's it. This is a simple problem on Bernoulli rule. Are you able to get it? Identify the problem. One of them must be algebraic. Find the first function derivatives and second function integration. Cross multiply with plus minus plus minus plus, that gives answer. Are you getting, guys? So this is my first problem. So let me go to the second problem now. Evaluate. Second problem. Evaluate integration x square into e power of minus 5x dx. Evaluate integration x square into e power of minus 5x dx. Now you see it is a product of two functions, x square into e power of minus 5x s, x square into e power of minus 5x. So x square is algebraic and e power of minus 5x exponential. So product of two functions, among them one is algebraic. So you straight away you can go for Bernoulli rule. Are you getting? So algebraic in order isolate, algebraic function comes first, then exponential is the last. Therefore the first function u is equal to x square here, and v is equal to e power of minus 5x. So u is equal to x square and v is equal to e power of minus 5x. So now what to do is u is equal to x square and v is equal to e power of minus 5x. X square derivative is 2x, 2x derivative is 2, and 2 derivative is 0. For first function we are able to find derivatives. Now let us go to the second function. For second function we need to find integrations. E power of ax integration, e power of ax by a. Now e power of minus 5x integration is e power of minus 5x by, what is a? A is minus 5. Previously it is only 2, now it is minus 5. So v1 is equal to e power of minus 5x by minus 5. E power of minus 5x by minus 5. This is our first integration. Now second one, in order to the second one, 1 by e power of minus 5 is outside. Now second integral you have to do. So you have to do integration of this. That is 1 by e power of minus 5 constant outside. E power of minus 5x integration, e power of minus 5x by minus 5. Minus 5 into minus 5 plus 25. Again 1 by 25 is constant outside. E power of minus 5x integration, e power of minus 5x by minus 5. Minus 5 into 120 minus 125. This is the third integration. Cross multiply. What is a cross multiplication? Plus minus plus minus plus minus. So what will get? X square into e power of minus 5x by minus 5. So 2x minus into 2x into e power of minus 5x by 25, plus into minus again minus 2 into e power of minus x by 125. Take 125 e power of minus 5x by 125 minus common, you get answer minus e power of power of minus 5x by 125 into 25x square plus 20x plus 2. This is my answer. Are you getting? Just for first function find derivatives, and for second function find integrals, then cross multiply with plus minus plus minus plus, that gives answer. This is my second problem on Bernoulli rule. So lot many problems you have to go on. So let me quickly move on to the next one, only 20 minutes more. So this is my third problem. You see guys, evaluate integration of x square into e power of 3x dx. Very easy problem. So can you do it for me? Integration, evaluate integration of x square into e power of 3x dx. Very easy problem. I think this is a repeatedly came for 5 marks. That's why I given in the slide, because already the first problem is of the same type. Why I given the same problem is, I think these two problems are repeatedly coming in exam. That's why I put it in the slide. So anyhow, what is the problem? You see, integration of x square into e power of 3x dx. So product of two functions, among them one is algebraic, therefore straight away you can apply Bernoulli rule. So x square is algebraic function and e power of 3x is exponential function. So now for algebraic function comes first the order. If you take isolate in isolate, a is the first and e is the last. Therefore algebraic function comes first, then the exponential function. So take the first function, u is equal to x square and v is equal to e power of 3x. So for x square you need to find derivatives, and e power of 3x you need to find successive integrations. So x square derivative 2x, and 2x derivative x derivative 1, that is 2, and 2 is a constant, derivative 0. E power of 3x, integration of e power of x, integration of e power of x is e power of x by a. Therefore e power of 3x integration e power of 3x by 3. 1 by 3 is outside. 1 by 3 into integration of e power of 3x, integration of e power of 3x is again e power of 3x by 3, that is 3 into 3 9, and in this case now 1 by 9 constant outside. So 1 by 9 into integration of e power of 3x, that is 1 by 9 into e power of 3x by 3, that is e power of 3x by 27. Cross multiply with plus minus plus minus plus. So what will get? X square into e power of 3x by 3 minus 2x into e power of 3x by 9 minus 2 into e power of 3x by 27 plus c. If you take e power of 3x common by 3 common, you will get x square minus 2x by 3 plus 2 by 9. That is my answer. That is answer. This is my Bernoulli rule. I think this is minus. Okay guys, plus minus, don't worry. So it may be minus. That's it. Yes, this is my third problem. Are getting guys? This is my third problem. So let me quickly next. Can you go for next problem, or you want time to note it down? But I think this is very same as the first problem. So I think no need. You can do it as a homework also. Nothing is there. I think this is a homework problem that I given, but I solved unknowingly. This is a homework for you. Evaluate integration of x square into e power of 3x dx. So let me go to the next problem. This is my fourth problem. Evaluate integration of x cube into sine 2x dx. Evaluate integration x cube into sine 2x dx. So I think you look at the problem first. What is the problem? Evaluate integration of x cube into sine 2x dx, product of two functions. It is a product of two functions. Among the product of two functions, one of them is algebraic function. One of them is algebraic function, that is x cube. So in a product, one of them is algebraic. Straight away you can apply Bernoulli rule. Now let us apply Bernoulli rule. In order to apply Bernoulli rule, what is the first function? What is the second function? I think you can able to guess now. Now you can able to know it. So what is that? It is x cube into sine 2x. X cube into sine 2x. X cube is an algebraic function. Sine 2x is a trigonometric function. In a order, that is a rule, isolate rule. Algebraic comes first and trigonometric comes next. So x cube is the first function, whereas sine 2x is the second function. So my first function is x cube and my second function is sine 2x. For a first function you need to find its derivatives, and for the second function you need to find its integrals. Now x power of n, derivative of x to the power of n is n into x to the power of n minus 1. So be careful. This is a previous problem for 5 marks. Now x to the power of n derivative is n into x to the power of n minus 1. So x cube derivative is 3x square. Now further derivative, 3 into x square derivative is 2x. 3 into 2x, it is a 6x. Now again further derivative, 6 into x derivative is 1. So 6 into 1, it is 6, and constant derivative is 0. So constant derivative, 6 is a constant, its derivative is 0. So what you are able to find, x cube derivative 3x square derivative 6x, and 6x derivative 6, and 6 derivative 0, and 0 derivative 0, 0 derivative 0, and so on. So all other derivatives will be zeros. So first, that's why our first function should be an algebraic function, show that there is an end for the derivatives, successive derivatives, and in turn it is an end to Bernoulli rule. Now what is my second function? It is sine 2x. So for sine 2x, sine x integration, sine x integration by substitution, you have to remember all you see. So my second topic in the in third sem is integration by substitution. By integration by substitution, what we are able to know is sine x integration is minus cos x. Sin x integration is minus cos x, that is the standard form. What about sin x integration? Sin x integration is minus cos x by a. So divide by x coefficient, that's it. Minus cos x. Sin x is minus cos x. Sin x is minus cos x by a, divide by x coefficient. So sin 2x integration is minus cos 2x by 2. Now minus 1 by 2 outside, cos 2x integration sin 2x by 2, 2 into 2 4. So further integration minus sin 2x by 4. Again here minus 1 by 4 outside, sin 2x integration minus cos 2x by 2, minus into minus, plus 4 into 2 8. Therefore cos 2x by 8. Again next integration sin 2x by 16. So for sin 2x successively we find integrations. So you need to know the formulas here. Integration of sin x is minus cos x, and integration of cos x is sin x. Integration of sin x is minus cos x by a, whereas integration of cos x is sin x by a. That's it. So if you know the formulas, you can directly do the this beautiful rule called Bernoulli's rule. So now for first function x cube, we are able to find derivatives, and at fourth derivative it is 0, and fifth onwards it should be 0. That's it. For sin 2x we are able to find success integrals. Now to apply Bernoulli rule, cross multiply, plus minus plus minus plus. So therefore integration of x cube into sin 2x dx is x cube into minus cos 2x by 2 plus 3x square into sin 2x by 4 plus 6x into cos 2x by 8 minus 6 into sin 2x by 16. So take common. If you take 1 by 2 common, what will get? X cube into cos 2x minus 3x square into sin 2x by 2 minus 3x into cos 2x by 2 plus 3 sin 2x by 4 plus c. So this is my final answer of Bernoulli rule. Are you getting? Very simple problem here, very simple Bernoulli rule. Look at the problem. It should be product of two functions, and among them one should be this algebraic function, and for first function find the derivatives, and for the second function find the integrals. Cross multiply with plus minus plus minus plus, that gives Bernoulli's rule. So this is my next problem and last problem on Bernoulli rule, and it is very similar to previous, but many students are confusing to do this problem. That's why I selected this problem to the slide itself, so that you will be clear about the problem. Yes, this is my fifth problem. Evaluate integration of x square into cos n pi by 7 into x dx. Yes, look at the problem. What's the problem? Is evaluate integration of x square into cos n pi by 7 into x dx. So this product, look at the problem. It has two functions, product of two functions, and one is x square and second is cos n pi by 7 into x. Since one of the function is algebraic function, you can apply Bernoulli rule. You can apply straight away Bernoulli rule. So what the many students are confusing here, in previous problem it is given sin 2x, you know the constant 2, well known number, sin 2 into x, but here cos n pi by 7 into x. So instead of giving a number, he has given some constant that is nothing but n pi by 7. So don't worry about that, treat it as a constant, look at it as not n into pi 7, just look at it as a number, a simple number, just like 2, 3, 4, like that. So look it as a number, then the problem look as a easy. But if you look, yeah, it is n into pi by 7. Oh, what is this? This is a big, n is a constant, pi is a constant, 7 is a constant, so multiplication and divisions are constants, therefore it is a simple a number itself. So look at it as a simple number, just like a 2, just like a 3, then the problem looks very easy, just like the fourth problem we did. So among these, the first function is x square and second function is cos n pi by x, because in a algebraic comes first and trigonometric comes next. Therefore x square is our first function u, and cos n pi by 7 into x is my second function. So for x square, find the derivative 2x, x derivative 1, 2 into 1, 2, and 2 derivative 0, 0 derivative 0, 0 derivative 0. So for x square, we are able to find the successive derivatives. Now coming to the second function, what is my second function? Is cos n pi by 7 into x. Integration of cos x is sin x. Integration of cos x is sin x. Integration of cos x is sin x by a. Integration of cos x is sin x by a. So integration of cos x is sin x by a. At place of a, what you are having? N pi by 7. N pi by 7. Cos of n pi by 7 into x. So integration of cos x is, what happens? Sin of n pi by 7 into x by n pi by 7. If n pi by 7 comes up, therefore 7 into n, 7 by n pi. 7 by n pi into sin of n pi by 7x. Now again integration of sin n pi by 7x. Integration of sin x is minus cos x. Sin x is minus cos x by a. So minus cos n pi by 7x by n pi by 7. If n pi by 7 comes up, it is 7 by n pi. 7 by n pi into 7 by n pi. 7 by n pi whole square minus. Again cos n pi by x integration is sin n pi by 7x by n pi by 7, n pi by 7 comes up, then 7 by n pi whole cube. So this is my third integration. Cross multiply. So cross multiply, you will get x square into 7 by n pi into sin of n pi by 7x plus 2x into 7 by n pi whole square into cos of n pi by 7x minus 2 into 7 by n pi whole cube into sin n pi by 7x plus c. This is my fifth problem. That's it, guys. So this is a problems on Bernoulli rule. You can see all 5 problems, it is a product of 2 functions, and among the product of 2 functions, one of them is an algebraic function. For algebraic function, we find derivatives at some stage. The derivative of algebraic function is 0, that is the end, and end to the Bernoulli rule. So this is a very simple, beautiful rule, Bernoulli rule. But in order to apply Bernoulli rule, you need to know what is a first function and what is a second function. And for first function, you need to find derivatives, that you need to know the derivative formula. And for the second function, we need to find integration. That means you have to know the integration of standard functions. So this is my Bernoulli rule, and now let me go to the next formula. Very important formula, many times it is coming. So last topic, very simple concept, within 5 minutes we can end it. So let me go to that one and we end this chapter, second unit today. So this is my formula, guys. I think, can I take the pencil? Yes. This is an important formula, coming many times, coming in examination many times. So look at it. What is that? Integration of e power of x into f of x plus f dash x dx is e power of x into f of x plus c. Are you getting? E power of x into, what is e power of x into? Function plus its derivative. E power of x into function plus its derivative, then the integration is e power of x into function. E power of x into function. Very simple and very useful. Many times it's coming in examination. Are you getting, guys? So now you see, you look at the problem formula, then we go to the problems. Very easy problems, single line problems. They are many times coming for 1 mark, and sometimes some of the problems may come for 3 marks. So this is, so what is the integration of e power of x into function plus derivative f of x plus f dash x dx? Then it is e power of x into function, that is e power of x into f of x plus c. Now look at the first problem. Evaluate integration e power of x into sin x plus cos x. Sin x is a function and derivative of sin x is cos x. So it is of the form integration e power of x into f of x plus f dash x dx. So e power of x into f of x plus f dash x dx integration is e power of x into f of x. Here f of x is sin x and derivative is cos x. So answer is e power of x into sin x plus c, e power of x into function plus c. Now the second problem, evaluate integration e power of x into x square plus 2x dx. Now x square is a function and its derivative is 2x. So it is of the form integration e power of x into function plus its derivative. The answer is e power of x into function plus c. Now third problem is evaluate e power of x into tan x plus x square x dx. Here function is tan x and tan x derivative is x square x. Therefore it is of the form integration e power of x into function plus its derivative. Therefore the answer is e power of x into function. Therefore it is e power of x into tan x plus c. Tan x plus c. Fourth one, evaluate integration e power of x into tan inverse x plus 1 by 1 plus x square. You see here tan x is tan inverse x derivative is 1 by 1 plus x squared. So it is of the form integration e power of x into f of x plus f prime x into dx. The answer is e power of x into f of x. So here is answer is e power of x into tan inverse x. Tan inverse derivative is 1 plus 1 plus x square, 1 by 1 plus x square. Now evaluate, the fifth problem is evaluate e power of x into x log x plus 1 by x. Now you can write x and x cancel, log x plus 1 by x. This is e power of x into log x plus 1 by x. Here log x derivative is 1 by x. So it is of the form integration e power of x into f of x plus f dash x into dx. Here f of x is log x. Therefore answer is e power of x into log x plus c. The sixth problem is evaluate integration e power of x into sec x into 1 plus tan x dx. Sec x into 1 is sec x plus sec x into tan x is sec x into tan x. So e power of x into sec x plus sec x into tan x. Here function is sec x and its derivative is sec x tan x. So it is of the form integration e power of x into f of x plus f dash x dx. Therefore answer is e power of x into f of x plus c, that is e power of x into sec x plus c. So that is very simple problems. All our previous questions you will get it. So let me go to the next problem, guys. So this is my problem. Seventh question, evaluate e power of x into tan x plus log of sec x. Tan x plus log of sec x. You see, integration of tan x, the derivative of tan x is sec square x. So derivative of tan x is sec square x. So tan x should not be f of x. So it should be formed, integral should be formed, integration of e power of x into function plus its derivative. If you take function as a tan x and its derivative is sec square x, so it is log sec x, not sec square. So if you take tan x as a function, its derivative is not log of sec x. Therefore you have to take the function as log of sec x. Are you getting, guys? Very simple point. If you take tan x as a f of x, then f dash x is sec square x. It is not there, it is log of sec x is there. So you cannot take tan x as a function. What you have to take? You have to take tan log of sec x as a function And what is a log of sec x? Log x derivative is 1 by x. So log of sec x is derivative is 1 by sec x into derivative of sec x, because at place of x we are having sec x, chain rule, into derivative of sec x is sec x into tan x, sec x cancel, tan x. So if you take f of x is equal to log of sec x, then its derivative is tan x. F of x is equal to log of sec x, then its derivative is tan x. So integration e power of x into log of sec x into tan x dx means it is of the form e power of x into f of x plus f dash x. So integration is e power of x into f of x, that is e power of x into log of sec x plus c. Are you able to get it? So this is my last problem. Here I just reversed it. Instead of writing log of sec x plus tan x, I just written tan x plus log of sec x. So you have to apply, you have to know which is f of x and which is f dash x. So what is function and what is derivative? If you take tan x as a function, its derivative is sec square x is not there. So you have to take f of x as a log of sec x, and log of sec x, you see in the slide, f of x equal to log of sec x, then its derivative is tan x. So log of sec x is my function and this derivative is tan x derivative. F dash x is tan x. So it is of the form integration e power of x into f of x plus f dash x into dx. Therefore it is e power of x log of sec x plus c. I think we are 45 minutes plus time, so it is a time to end here, guys. So we seen two things here. First one, a Bernoulli rule. What Bernoulli rule says, uh, instead of applying repeatedly product rule, we have to apply Bernoulli rule, and there is a condition for Bernoulli rule. Among the product of two functions, one should be algebraic, so that there is end of successive differentiation and there is an end to the Bernoulli. So that is a condition of Bernoulli, and a very beautiful rule. You can apply the Bernoulli rule whenever there are a product of two functions. We have to evaluate integration for product of two functions, and among them is a algebraic preferably a greater power of x. That's it. And in order to smoothly solving Bernoulli rule is you have to know the derivative formulae and integration formulas. And coming to next problem, next formula is integration of e power of x into f of x plus f prime of x into dx is e power of x into f of x. That is integration e power of x into function plus its derivative is e power of x into function plus c. At about 7 examples we did, and all the 7 problems are previous questions in examination. For sometimes they came for 1 mark, and sometimes same problems came for 3 marks. So that's it. That is end of this chapter. Now let us go to the homework part of you. So what the homework is? So evaluate integration e power of x into sin inverse x plus 1 by square root of 1 minus x square. Sin inverse x is my function and its derivative is 1 by square root of 1 minus x square. Straight away the problem. Evaluate, second problem is evaluate integration of e power of x into cot x plus log of sin x dx. Here cot x derivative is minus cos x square x. It is not there, therefore I just reverse, write down a plus b can be written as b plus a. So write log of sin x plus cot x, and derivative of log of sin x is cot x. You can apply. And third one, evaluate e power of x into 1 by x minus 1 by x square into dx. So 1 by x square, derivative of 1 by x square is minus 1 by x square is 1 by x. That gives answer. So all are in a formula based, that is integration of e power of x into f of x plus f dash x dx is e power of x into f of x plus c. So this is my homework part, and this completes first 2 units, that is total indefinite integrals. So next class we are going to start definite integrals. Very important topic, and then we go for applications. Okay, so we covered indefinite integration in first 2 chapters. Now learn all methods, practice them, and by heart art formulas. We use all these formulas in definite integrals too. So by heart them, remember them. So next class we start a new lesson, that is third unit, definite integration, definite integrals. So until then, bye. Thank you. See you guys. Stay home, stay safe, stay healthy.